My name is Pete Kay. I'm from the Surface engineering team in Redmond. Excited to be here today. We're going to be talking about, as you probably already know, a little bit behind the scenes of what we do from an engineering perspective when we make our devices. We have a little bit of a story that we're going to tell today. It's going to be the people behind the products and how we make them, a little bit of our culture, and then we're going to get into the details of how we use those people and the culture to make one of our products. We're going to go into the details of Surface Book. We'll leave some time at the end for questions, so we want to make it interactive at the end to make sure we can answer some of the questions from the group. So as you know, we have a portfolio of devices, and the teams that make these devices pretty much sit under one roof. We have a couple different facilities, but what you're going to see and hear about today is how we use the engineering technologies, both in hardware and software, and the test facilities in Redmond to make the whole suite of devices, whether we're talking about HoloLens, Hub, or any of the Surface products. A little bit about myself before we get into the details. I've been doing consumer electronics for about 15 years. I'm an aerospace engineer by trade, and it's pretty neat to think about how the stuff that happens across industry, whether it's aerospace, automotive, or consumer electronics, is starting to come onto a mainstream. And by that I mean designing, testing hardware, and integrating software in those features. We're seeing that in a lot of the products we work with today, whether it's a satellite, a car, or a device we're working on. I've been with Microsoft for 8 years, and I started working on the big Surface table. That team is a team that morphed into making the Surface devices that we have today. We started with a small team, and now we're over 800 strong. And we work multiculturally and internationally. We work with teams in Redmond, in China, in Oregon, and other parts of Asia, tightly with our partners as well. What you'll see today is a little bit of the background of the culture we have as a team in designing products. And it's something that we talk about, but it's also something we practice, and you see it when you're in the field using our products. You see it when you talk to our customers. That culture reflects back onto the team in Redmond. And we talk about the products we made. We take great pride in those products. And what we like to talk about is that the products are a reflection of the people who make them. And by that, we mean the attention to detail, the attention to the material we use, the testing we do on our products, and then how those products get deployed in the field. Our team takes great pride in how those products get made and deployed. And the reason why is because we have customers. We have customers that use our products, and we like to keep in tune with those customers, and we realize that people have a choice when they're picking the products. And when they choose products, those products are also a reflection of themselves, whether it's a brand or actually the device they're using and how they use the product. And so this whole big picture of us taking pride in our products and our customers taking pride in the products they purchase means that we have to think like our customers and be in tune and listen to our customers. And so a lot of what you're going to hear of today is how we try to keep our ear to the ground and listening to our customers and taking that feedback and incorporating into our future products. This is a picture of the team working in Redmond, actual mechanical engineers that worked on Surface Book. What they're doing in here is they're designing new products that are about to come out. You can try to look for details in here. You're not going to see any signs of roadmap information. But this is the team, pretty much DNA-wise, that worked on Surface Pro 1, Surface Pro 2, 3, and 4, and led the way on Surface Book. And we're going to show a video of some of the work they did later on in the presentation today. And I have some parts of the stuff they work on. But it's a very collaborative environment. Inside of our culture, we have a couple things. One is be human, so everyone has a voice when they're at the table, all of our engineers, all of our test teams. The other one is we have something what we call fail fast. And by that, we mean we're able to come up with ideas, prototype them, test them, validate if they're in or not, and then move on. So they become part of the design or they don't become part of the design. And so when I show you some of our test facilities and test capabilities later, you'll understand what that means. But what does it mean to make hardware? I talk about the hardware designers and hardware engineers. What we try to do, this is kind of a glamorous shot, but it's kind of the reverse of glamour. We want the hardware to fade into the background. We want the software and the application and the person using the device to be the forefront of the experience. And so that hardware means that we have to take all technological barriers out of the way. And so the person could get done what they need to get done. That's how we make the most productive devices on the planet. And so as a hardware engineer, telling people you want to make stuff that fades in the background isn't necessarily something you can put a feather in your cap on, but essentially is in the ethos of what we try and do. We try and make the hardware fade into the background, no roadblocks in terms of what the person's trying to get done, so that we can make our customers more productive. So we're going to talk about a life cycle of innovation. This life cycle, let that slide build a little bit, sorry about that. This life cycle starts kind of an idea, and that idea is a V1 of a product. We go into design, we go into rapid prototyping of that design, and what that means is we're trying to come up with the right combination of features for our product. As you can imagine, when you start out a product, you have a huge list of all the asks that need to go into that product. Try to put those all in, and you're going to burst the bubble from a program management perspective of either cost, schedule, or scope. And so you find the right balance. What fits in the timeline we're trying to ship, what fits in the cost that we're trying to ship, and gives the features that we need for this generation of that device. That's what happens in design. And then you get to rapid prototype, and you get to test your assumptions and do what we call fail fast. After rapid prototyping, you iterate your designs, and we move on to development and testing, which sets you up for production. And by development and testing, we're saying, how are people going to use our products? What software are they going to run on it? What environments are they going to put them in? And we'll test to those. And you get a lot of valuable information from that testing that you feed back into the design. Then you go to production, and production, again, is like launching a whole product, because once you start to make, we have a saying, it's real easy to make one of something. Once you make 10 of them, you start to learn lessons. You make 100 of them, 1,000, 10,000, you get the picture. Once you get to 1,000,000, you learn a lot from making them. And so we treat production like it's a product amongst itself. Going to market is also a big deal. Because of the attention we pay to detail when we're designing our products, we want to make sure that story gets told the right way. And after we launch, we listen and learn, and we feed back into our next generation of products. So our designs are what we call homegrown. And if you look here, you're looking at one of the first iterations of Surface RT. What is it? It's literally a piece of cardboard with black foam cutout and a black piece of tape on the back, a white sheet of cardboard paper magnetically attached to the bottom of the device. And the idea when we were set out to make our Surface devices was to make people more productive. And this idea of being able to type on a tablet was the first idea we had. And so we started literally attaching a keyboard to a product. And then we said, well, what is the user going to do with it? How are they going to type on this device? And that's where the kickstand was born. And it was literally a designer who went into the closet, grabbed a piece of tape, and stuck it on the back, and came up with what you see here. And so this is literally the first Surface product before they started having screens and actually full capability. And you're looking closer, you see the actual parts that made it up. And we went through many iterations on trying to get it right. What's the right angle? What does it mean to be productive? But this is how the start of a new category of defining new devices got created. And literally, this started in a small building and has since expanded. And what do I mean by that? Our engineers are still encouraged today to do the same thing. We have a facility set up. It's called Building 87 in Redmond, where we have CNCs, we have fabric shops, we have materials available for engineers to go in and fail fast, put new ideas into implementation, try them out, and come back with features that will make our products better. So these are the iterations that happened after that cardboard design. It's funny to look at that design and say, yeah, that's what you ship. That's just not how it happened. We went through over probably 300 SLA stereolithographic models of plastic designs that would allow us to feel our product and see how it would look. During this time is when you would get an electrical engineer coming to you and saying, hey, this is the processor we want to use. And then the battery engineer would say, if you're going to get that hours of battery life, you need a battery this size. An RF engineer, an audio, a microphone engineer, display. So you get all these different parts starting to come together, and you start integrating them architecturally into a design. But again, we're focused on our customers. We want to know how our customers are going to use them. So we'll make parts and put them in our hands to actually try them out. So again, first Surface RT, Windows 8 UI. This is an SLA model of just plastic parts with literally a sheet of color printed paper of what the display would look like. What's the resolution? What's the content on the screen look like? So none of this is real, right? This is all just paper and fabric, paper, plastic, fabric, and printouts on the screen. But this is how we do the beginning of products. And then we get into a more detailed design. We start the parts I just talked about. What does the electrical team have to do? How does the layout look for thermals in terms of dissipating the heat in our devices? What's the actual mechanical design of the product? All the way down to the details of the USB ports. Everything we do is custom inside for Surface so that we can make the device as fit as possible, both thinness, high reliability, and also mass producible. So when we get into mass production, we're able to make millions of these parts. So this is the USB port on our Surface devices that has to fit the chamfer. We basically come up with a design. We'll test it out in Redmond in our labs, prototype, and then we'll do signal integrity testing to make sure it does what we want to do, and we'll ship it off to mass production. And with all those designs and with those early prototypes, we came up with the, if you remember, the Surface journey that we've been on to date, and I'll get into a little bit of the Surface products. But started out with Surface RT, which you saw in those models, and we got to the point where earlier this year we have the latest Surface Hub, and the series of products that we've been on since then. And you'll see as you go down this progression, the feedback we've got and the learnings we've got from our customers in terms of making our products better and making our customers more productive. I started out as the lead PM for Surface Pro 1. I like to call that my baby. I won't tell that to my daughter now. She's younger than Surface Pro 1, but she's my baby. But literally spent a lot of time and attention and details in getting Surface Pro 1, the pen, the kickstand, the performance right. When we were making it, people were telling us, you'll never be able to put a core processor into a tablet. It's going to get too hot, and it's going to get too loud. You can't have a tablet with fans. Fast forward 4 years later, and it seems normal to have a core processor inside of a tablet. All the OEMs are doing it. People told us that people aren't going to want to do inking. Inking didn't matter, and inking has gone away with the old Microsoft tablet PCs from the early 2000s. Ink has become a first-class citizen. Since the days of Surface Pro 1, we've iterated on our pen, our inking design. Huge investments in bringing inking to be low latency and low parallax so that we can try to mimic what we're doing on paper, to the point where you now have not only inking in latest Windows 10 version as in the tray icon, but also other competitors bringing inking to the forefront. Where they said they would never do it, they're starting to launch pens. So inking and digital devices are something we're going to see more and more of. So two-fan device on Surface Pro 1. This was also the form factor for Surface Pro 2, so I don't have any glamour shots of that. But the screen was optically bonded, and we were starting to learn what displays meant to people who were trying to be more productive. And we got feedback, and the feedback that people using Pro 1 asked about mainly was, we want a bigger screen. Like, you want us to be productive, we need more space. They also asked for, let me think, more angles on the kickstand and longer battery life. Literally, when we launched Pro 1 at 4 hours of battery life. So we got to Surface Pro 3, which we knew we wanted to get to while we were just finishing Surface Pro 1 and getting out the door, but we knew technology had to catch up. On Pro 3, we had a custom-built display. It's a 3:2 display. It's something that matters deeply to us on our Surface devices, because what we try to do is we try to make the lightest, most compact devices, but still let our users be productive. What a 3:2 display gives you, it gives you the maximum space in the vertical format without growing horizontally. So what does that mean? Most of the stuff we do is vertical, whether it's a web page, whether we're writing a document, or it's up and down. And so by having a display that goes up and down with the most space and not having to artificially grow it sideways, you don't have extra weight or wasted real estate or wasted power. 3:2 displays are super important for us. We have them on our products today. We have it on Book. And what you'll start to see is more and more people are going to catch on to what it means to have a 3:2 form factor. We did some pretty cool things with Surface Pro 3. We have our Surface Connect for docking. Again, we had the 3:2 display and the full kickstand. This was really the flywheel for us in terms of people understanding the value proposition of what a Surface product was. And then we carried that on. Well, let me get on the insides real quick. We went from 2 fans on the device down to one fan was actually kind of a big deal. And we took this huge motherboard and started to condense it. We're starting to get more optimum when working closely with Intel as a partner. Before they were working with us, they work closely with OEMs, they still do today, but they're starting to lean on us more for what does a leading edge design look like? How do we take advantage of Intel silicon to make an architecture that is a small form factor but yet high powered? And so with Surface Pro 3, we're able to go down to one fan, which was pretty remarkable in terms of the power that we were dissipating and condensing a lot of the electronics in the device. We also refined our pen on Surface Pro 3. Pen started to matter more. We went to an active pen digitizer. It allowed us to go thinner on the device. We got a click note function on this pen as well. And we got higher accuracy and lower latency with respect to the writing. And so Surface Pro 4 took advantage of a lot of the goodness from Surface Pro 3 and added onto that. Improved battery life, more resolution on the display. Actually, a bigger display. We went from 12 inches to 12.3 without growing the device. We kept the 3-tube form factor. We kept the full friction kickstand. And we improved the typing experience. Again, listening to our customers. Those are the main feedback we got. They wanted a bigger trackpad on the device. They wanted a better typing experience. And they wanted more power. And so we switched the 6th generation Skylake processor on Surface Pro 4. We also got a lot smarter on thermals. So you start to see the internal architectures of these devices and starting to get more clean and more efficient. And so you see the Intel processor is the green area. And you see our fan is up here. And so the fan is used on the i5 and i7. The M3 is a fanless device. We also learned a lot about doing passive cooling. So we're able to keep the fans off longer and do a lot more passively. So that means when the fan is not spinning. And Surface Book. So that team that worked closely on Surface Pro 1 is the same team that launched Surface Book. And they took all that motherboard design that I just showed you, and they condensed it to something as small as this. So this is the motherboard for Surface Pro Surface Book. Again, single fan solution. You're able to dissipate i5 and i7 heat through the device. Carry a full SSD on the device. And so do some really cool things with the inside. And this is a closer look at it electronically in terms of what we're trying to do. Also, the first time we did a split architecture, we were able to put graphics processing in the base, along with the computing technology and Intel processing in the top or clipboard of the product. So that was kind of high-level overview of the process. But what I wanted to get into is a little more details of how we use that process specifically on Surface Book. And I talked earlier about this listening and learning, and I talked about the spark. So even from the earliest days of launching Pro 1 up until the Surface Pro 3 launch, we were getting some same questions back from people. 12 inches still wasn't big enough from a screen size perspective. Power was a limitation. People wanted more processing power in their devices. And there were people that, even though they loved the idea of this 2-in-1 with this fabric keyboard attaching magnetically to the bottom, kept asking for a real keyboard. They said, give me that keyboard experience. We want that keyboard experience. Whether it was press or actual customers just said, I want to buy a Surface device that gives me the laptop experience. And so that's the genesis that led to Surface Book. Literally, we took those attributes, put them into our design process, along with the same engineers that gave you that cardboard cutout with the black tape on it for Surface RT, and said, what should Surface Book be? Mind you, it didn't have a name at the time. It wasn't called Surface Book, but it was going to be our next Surface product. Surface Pro XL, something was the idea. And what we came up with was, okay, if this thing is going to be a Surface, we want to have pen, we want to have touch, so that means it has to be detachable. But we need a solid-state keyboard on the device. So we have to come up with a way of combining those things. And if you have a solid-state keyboard on the device, you have to make sure the device doesn't tip over. And you have much more real estate than we used to have, where you have these engineers who are pushing to fit everything into a really thin form factor and into one part of the design, said, I have all this room in the quote-unquote keyboard now. So then the idea started to generate. Well, why don't we use that for more processing? We can put a graphics processor down there. Mine's exploded. We put more battery down there. We can get over 12 hours of battery life. Again, mine's exploded. Started to have all these ideas. But you generate all those ideas, and then you have a list of challenges and problems. Never designed a device that detaches and there's processing power on the bottom. You're gonna make Windows mess up every time you pull it apart. Or I never designed a device that is really heavy up top. You have the kickstand on the Pro that lets you carry the weight, but what happens when you have your display, battery up top, your SSD up top, your memory up top? You start to get heavy. And so that's the genesis of the ideas that led to the challenges that we had to solve on Surface Book. And so came the idea of design and what we call failing fast. So that team you saw sitting around the table actually started to think, what do we got to do? How do we have to solve for this? And a lot of the focus and attention around Surface Book went into the hinge design. And the hinge design is multifaceted. It's not just the mechanical part of the design. It's how does that design let us securely attach the top and let us know when it's attached? Do you think a lot of the 2-in-1s or detachables today, they either just pull apart or they have a mechanical switch, but the software doesn't really know when it's attached or not attached? Also, how do you make the hinge extend the wheelbase of the bottom so that you can get more leverage, so you're not tipping the top over when you open the device? And so these were a lot of the early ideas, literally taken from pictures where you'll see quotes of the themes the team was trying to go for. And early on, they work and they take all the limitations out of the way, remove any barriers they have, and said, if there were no constraints on what I was doing, whether it's cost or space, how would I do this? And you can actually see the pulley mechanisms they were thinking of that said, as this thing goes up and down, how can I control the top and bring it towards me in terms of opening? And they came up with this gear concept and also this link concept on the design. And they took that a little further in saying, how would I use this to detach and attach and make a seamless experience? And so what happens next is you go into prototyping phase. The team literally walks in the building next door where we have 3D printers, CNC machines, and can start doing prototyping. And you see that the picture before actually gets built into a gearbox where you can turn the gears and that thing would lift itself up and turn itself down. And you said, okay, this is an idea and concept. How does it work? And the stuff running through here is actually conductive material that says, I need to pass signals from the bottom up to the top. And so we're able to test the electrical and mechanical at the same time. And this gets reformed as you go from left to right to the point that delivered the final product, which is a short video clip showing Surface Book opening, extending the wheelbase, and how that idea got converted into an actual design. And I'll show you a little bit more on it as we get into the rapid prototyping phase. Because what happened now is the team started to latch onto a design. They said, okay, we have a design that will help us get to what the customers were asking for from a layout. We have the bigger screen, we have the bigger keyboard, but how can we make it work in market? And so these are some more prototypes of what you see. This would be a form factor prototype of how the weights would feel, so weight distribution and actually putting it on your lap and seeing how it feels. And then you get here and said, all things unconstrained, how could I make the detach mechanism be software controlled? It's pretty difficult to try to comprehend. It says, I'm going to tell the software when I want it to let go of the top. And so the team investigated something called muscle wire. And what the muscle wire does is it's a wire that contracts when you give it energy. And so software-wise, you can tell the device, I want to detach, and it will send a pulse to the muscle wire, and the muscle wire can contract. So think about the pulley system you saw, essentially bringing all that system into smaller technological parts, and then letting the software tell the muscle wire when to contract. And essentially what the contraction does is it then releases the top from the bottom. And so what the team did is they implemented a friction mechanism. How many of you ever worked or had the little Chinese finger locks when you were kids? They're kind of party toys, they're red and green. And you know if you put your fingers in them, the harder you pulled, the more your fingers would stay together. So essentially what happened, it's called a friction fit. And so there's a friction fit mechanism that's working between the keyboard and the clipboard that won't ever let you pull the top and bottom apart. So there's essentially one device, like a real-life tied mechanism. But then if you release that friction by simply pulling up on the device, the bottom will come right out. And so this will be up here later for you to try, but putting it in, the bottom is stuck. It's a super rigid device, and it won't come out. But by simply, what's happening here is my two fingers are trying to pull on each other, and the friction's getting harder. But when I release that friction, there's a little roller inside. This part slips right out. So you take that, And this is a 4X model of what's happening inside of Surface Book. And it's hard to see from the back. I gave you warning at the beginning of the talk. If you sit back there, you're not going to see what's going on. But there's a wire that runs through here, and this is essentially muscle wire. And so software-wise, we can tell the device wants to detach. Why does software matter? Well, if you're running stuff on the GPU and the base, or if your battery is low on top, you want to protect the user from detaching. But when you're ready to detach, you simply tell the device you want to do it. And the muscle wire, I'm going to be the muscle in this demo. The muscle wire will pull on the device, and then that friction element comes right out on the bottom. And so when it's not active or when it's contracted, there's no power being applied, and the bottom and top are simply a laptop. So this is the way we made a laptop turn into a two-in-one using software-controlled mechanism using muscle wire. Muscle wire is not something that exists in the consumer electronics industry. It's actually started off in aerospace, so a little bit tying into talking about how these industries are coming together to make gloves that will actually make astronauts stronger when in space. So giving a little actuation or energy to the muscle wire lets you grip stuff when you know you want to grip it, and then release it when you want to release it. And then working its way into autofocus lenses on camera, so you use wire to actually get that adjustment using electrical current. And lastly, into brakes into cars. And so when we went and talked to muscle wire specialists, they said, what are you guys doing? Like, is this the car thing, or is this some aerospace glove? And we said, we're making a Surface device. And they were super excited to see how we were applying the technology and something they worked on with us to develop. Joe Galt is one of our engineers in Redmond. He worked on the hinge on Surface Pro 1. He was the muscle wire specialist on our team. And so here's a short video of him.
First thing we'll do is dock. So it just snaps on without any problem. Snapped home. And then to disengage it, the magic handshake happens, which in this case we just push the button, it pulls the pin, and it comes off. So let me show you what that, if I don't push the button, then it's snapped into, it's locked here, so I physically can't pull it off. I'm going to pull this and then...
When Joe made this video, he had no idea that we'd be showing it 2 years later.
Close up of the mechanism. So we're about to, it's about to attach, so you'll see the locking pin move back here and out of the way and then snap home. So now it's locked. I can't, I'm trying to pull it apart, but I can't. And then now I'm going to disengage, pulls back, and snaps off.
So you can see it's a very rudimentary prototype, but it's what got us thinking on, is this possible? So the encouragement to fail fast let Joe go build that prototype in our shop with literally a 9-volt battery, working with our partners that make the muscle wire, and come back with, hey, this could really work. We have the friction fit design. We have a way to software control a latch mechanism. So putting a graphics processor in the base of the device isn't as far-fetched as people think. And so we continued on the rapid prototyping and said, now we know how to make the design. What would the overall form factor look like? You can see these are different designs of Surface Book that probably have never been shown outside the building before, where we looked at different concepts of how big does the base have to be, how big does the top have to be with the base being super thin, more of a Surface Pro-like, versus the one we actually ended up shipping, which is this, this structure you see here with the dynamic fulcrum hinge. And the idea we got to was, as we make the device bigger on top or more heavy on top, we want to have as much wheelbase support as possible. So we got to the design. We got to a place where we knew that the design would work, but we wanted to meet the fit and finish requirements of a premium device. And so what does that mean? It means going out and using the materials that we've set out to use on Surface that are leading edge in terms of our industry. We're doing something with magnesium, which is an alloy that's lighter than aluminum that lets you do thinner and lighter, but still structurally relevant enclosures. And so we made the device, the top of the clipboard on Surface Book, 7.7 millimeters, which is the thinnest anyone's ever put a Core i7 processor in, with vent holes all the way around and enough structure in place to handle the robustness of drop testing and other reliability requirements. And what you see here, this is actually the loop for the muscle wire with the detach mechanism in it. So it's this is kind of a 4 times or 400 scale version of what you see here. And so we needed enough room in the design to handle what we were going to put there, with the fangs on the bottom that become the friction elements to hold the keyboard together. And then from a fit and finish perspective, this is a machined part. So this starts off as a full billet of magnesium, where we go ahead and CNC all the features you see here, including the vent holes all the way around the side. And this design, again, from the way we design products in Redmond, gets done in a prototyping phase using CNC machines that are on site. So fully automated design process gets done in Redmond before we ship the design off for mass production. The other unique part that you have on Surface Book that many laptops don't have is 3 cameras, right? Most laptops today will have 1, if 2 cameras. And so we have a normal front-facing camera for your teleconferencing, Skype, Windows Hello camera for login, and then an 8-megapixel rear camera with autofocus, which is huge for a laptop, right? No laptop typically has a rear camera on it. But in designing a tablet, a rear camera is expected. By putting an autofocus camera on here was another way we spent listening to our customers. So Surface Pro 3 got launched, and we found lots of people starting to use it. Actually, people wanting to scan or check documents with their focusing of the back, or scan instructions and put them into email. We had a customer in Japan. He's an older gentleman who's been doing machine shops for a long time. We got to meet him and talk to him and bring him over. But what he was doing is using his Surface Pro to take pictures of his work instructions and send them to people. But his Surface Pro 3 didn't have autofocus on it. And so what he did is he ended up himself designing an over-enclosure that went on with 2 lenses that would let him do autofocus for documentation. And he sent it to us and said, hey, what about this for an aftermarket device? Of course, we had been listening to the feedback for autofocus, and we already had autofocus in the plans, and we were able to disclose it to him, and he was laughing. But our mechanical engineers got to a bonding moment with him on the amount of effort and energy he went into to design an autofocus overlens for his Surface Pro 3 so he can get stuff done. Other than the magnesium enclosure, we also talk about our displays, and I'll talk about them a little bit later. Optically bonded displays with custom chips inside for pen and inking. And so what we see on Surface Book, either in clipboard mode or in what we call draw mode, people are using it to get inking done. So again, not something you can do on a normal laptop, only something you can do on a device that has pen and inking capabilities. Which led us to the final fit and finish of the product we're shipping. The final version of the hinge, not far off from the early prototypes of what we're shipping. Magnesium enclosures, both top and bottom, and the full performance of a device that is ready to go to production. So we're done, right? Go to production, ship it, it's over. That's not typically how it works. So we have a team that works really hard on the design, and then that same team is the team that takes the device to production. So what does it mean to go to production? I mentioned it earlier, but basically when you go to production, we treat the process as if it's another product. And so I wish I could show you a bunch of pictures of our production line. We're not allowed to. If you ever are in China and want to go to China, you can come and ask to visit our facilities. We'd be more than happy to take you in and show you some of the stuff. But the pictures don't come out for confidentiality reasons because of the stuff that we're working on. But I thought what I would do is talk a little bit about the testing that we do while we're in China. And that testing is shown here in a video of the testing that we do for our hinges. And so this is what we call reliability testing. And so our hinges are designed to meet a certain life of open and closes, whether they're the hinges on Surface Pro 3 or on Pro 4 or even on Surface Book. And so we have the automated facilities that let us go in and do testing on our devices. We also do a lot of environmental testing, whether in chambers, high heat, high humidity, which is accelerated life, or we also do drop testing. And so we have a video of a slow motion drop test. It's hard to get the magnitude because you don't see the height, but this is a Surface device being tested via drop. Makes me cringe. But that's onto a hardwood floor from 36 inches, essentially. You can see by how high up it bounces, survives the drop. They don't all survive. Early on, you're typically failing. Corners are the hardest. Corners with connectors are even harder. So this is the most robust test that we run. Gorilla Glass helps with the flexibility. The magnesium enclosure we used is designed around that, and there's actually reinforcement parts on the inside of the device. that gets screwed to our corners. So we have our magnesium enclosure, and then we put reinforcements on the corners. There's one here that you actually see a steel insert around the side to help with drop. So we do our best to help with reliability and robustness in terms of the design we're shipping. In addition to that, so that's reliability testing, we do what we call design testing, or testing the design to make sure it's meeting the intent of the requirements you set out with. Gopal is one of our head engineers from our acoustic team. He's working in the acoustic chamber that we have in Redmond. It's in Building 87. It's kind of got a little notoriety now in being the quietest place on Earth. We've gotten down to minus 20 dB in this chamber. We use it to test intentional and unintentional noises. So easy to know what an intentional noise is. How good are your speakers? How good are your microphones? Are they doing what you want them to do? Unintentional noises. Make sure your fans aren't loud. Electronics, believe it or not, they want to talk. So capacitors and resistors want to do what we call singing. We hate it. We put them on our devices. We get in the quietest place on Earth, and we listen for that buzzing sound. If you've heard it before on device, you know what I'm talking about. We do our best to engineer that out of a product. And then lastly, the sounds that kind of fit in the middle. How does a keyboard sound when you're typing on it? Does that matter to anyone? It matters to us, and we put it in the chamber, we measure it, and we measure it versus what users expect, and we make sure the keyboard sounds like people would expect it to sound. So here's a picture of the chamber. Kind of get the magnitude of the chamber from the size of the door. And then we get to our final product, and that's the product that you see here. That's our 13.5-inch screen. It's 3,000 by 2,000 pixels, optically bonded, color calibrated. Color is something that's very important to us, and we're pushing on from a design perspective to get to a place where we're shipping high-color displays that matter to people who are using them. And then talked about keyboard and how it sounds, how it feels, quiet and comfortable. We get a lot of great feedback on the Surface Book keyboard and the work we put into it. I pulled the slide that literally came from our design process that we did after something we call EV2. So it's after you build some prototypes and actually test them out. And what we did is we measured how we're doing versus our target. This is kind of what I would call inside baseball, but really matters to us. So we set out and says, what matters when you're making a good keyboard? The attention you're paying to that keyboard. Travel, force to fire, spacing, pitch, dish, texture, and sound, which I just mentioned. We build our first 100 devices. We test them. We put them in that lab. We say, how are we doing? Someone gets a bad grade. This is their bad report card. But then they know what they need to go fix before you do the next build and before you actually go into production. I thought we were on production earlier. We're on production now. So I'm going to give you the line on coming to China if you want to come. But the message I want to get across to you is when we go into production, we spend a lot of time on what does it mean for the products being made and how do you test them, and making sure that each device that leaves the factory meets our requirements. So this mathematical equation you see here is how we test our speakers. And so that matters to us all the way down to the detail of how speakers are tested. I have a picture of a keyboard here. We do a lot of machine to fit on our devices. What it means is each device is custom made. So when we put a trackpad in, we measure the trackpad we're about to insert in the device. We'll cut a hole for it on the line to match that exact trackpad, and we'll pull it in. So if you're looking at a Surface Book and you look at the line cutouts around a trackpad, you'll notice how precise they are. And then the time and energy we spend in going to market and what that means. And I talked a little bit about the details we pay on the product. Well, that same level of detail is the attention we pay when we go to market. Making sure we tell the value of our product, the story to our customers and those who are listening. And a lot of the work that goes into making the production videos of when we go to market are the same people that made the product, believe it or not. And the renderings we use to go to market are usually the renderings that we were using when we were designing to set out the device, and the same ones we use to machine the device. They're not generated offline or separately. So the attention to detail you see there is the same stuff that gets made on the product. We have our product day and devices day. That's where we tell the message to the world. And then we continue to tell the story, whether it's web or in customer meetings, to make sure people understand what it means to use Surface devices. You probably have all seen the video for Surface Book. Something excited again. This was done by the team in Redmond. The same team that did those sketches early on is the team that worked on this video for when we launched to market. I'm not going to play the video. I'm going to do our best to wrap in a couple minutes and leave a few for questions. We're listening. I told you that for feedback into our devices. We're also listening to how we make improvements in our devices. And so we have our ear with our customers in terms of making improvements. I'm sure you guys all know who Bill Gates is. He's very vocal in what we're doing and making sure we're always getting better. But we're happy with the feedback we're getting on Surface Book. There's been some great press. There's been some awards that we've won. We're lucky enough to win a GeekWire award. That's the #1 geek accepting the award. That's me on stage at GeekWire. Super pumped to get out there and accept it on behalf of the team. We were surprised when we won it because there was a lot of other really cool devices that were being nominated. But it's a testament to how the design and the push we're doing from an engineering perspective is really leading the way. And then the thing that matters most to us is customers using our product and seeing the benefit. And this is Joel Henry, who's using a CAD program to do his work, both personal and professionally, uses Surface Book in every way we intended it to be used. The power of the processor, the big display, the great keyboard, and then even inking on the clipboard design to take notes and do what he wants to do. And so we're really super happy with the feedback we're getting from our customers, and we're hearing more and more stories like this. And so this is a quote from him that just is essentially what we've designed. The stuff we intended to do when we set out to make the product is how the product is being used. I have one video. I'm going to show it. This is our lab in Building 87, and then we'll do questions and answers.
Microsoft is all in on making Surface one of the greatest hardware devices in the world.
This building allows us to design, build, and test, and iterate over and over and over again to reach perfect products.
8 separated labs that are now together under one massive roof.
The fidelity of the problem solving, it's at a different level.
As a hardware designer, my expectations were blown away.
It's that place where people come together to collaboratively design something. It's a 100,000 square foot building, and we've consumed the whole thing specifically for hardware labs.
CNC machines, laser cutting machines, water jet machines, a huge spray booth.
There's polyjet machines. These are all like rapid prototyping devices.
Down to the micron level of accuracy.
Having everything in one place is really incredible.
We'll see somebody working on a model that's totally different than what we're thinking of. It can inspire like a new creative way of doing it, and that happens all the time.
We had a meeting where we talked about a bunch of ideas. We're going to have the same meeting tomorrow, and we're going to look at the parts on the table. I haven't seen anything like it.
We seek perfection. That's the goal for Surface. Perfect products. Now, this building allows us to get closer and closer to perfect.
Cool. And so those are actual facility that we use every day and real engineers that work on those devices. So I ran a little long on time. We'll do some questions, and then we have an announcement for before we go.
Devices are unbelievably great premium devices, but before you had the picture of the NASA engineer up, right? My customers in the financial markets, in some ways, are similar to the engineering types, and I would love to be able to upsell and deliver them a great solution. But when it comes to the accessories, for example, the Surface Book, especially now that you have the graphics processor in the keyboard. I need a VESA mount with a graphics processor, so when my customer goes in, we plug it in with that really locked-in feeling, all right? Get it in his rack with his other 5 or 6 monitors, drive, in this case, financial applications, and not be penalized for having this great mobility solution that at the end of the day, he takes his desktop with him. But those accessories to make that happen and to really prove, because, it would pull through a lot of other Microsoft devices.
Yeah, so my engineering brain wraps around like what exact accessory do you need, and I probably won't solve it. Yeah.
Graphics Pro processor,
Yep.
a VESA mount.
Yep.
So, again, the same thing with the CAD cards.
Yep.
They're in front of multiple monitors today.
Yep.
Right? It's a handicap not to have multiple monitors. It's nice that you can do your business on the single monitor when you're mobile.
Yep.
When you sit down to do business in your office, you want that rich environment, and it further drives the capability of the Surface and the Windows 10 platform.
Yep.
Back to the full PCs.
Yep, and so what we'll do is we'll probably talk later offline, but knowing that the stuff that we promote is our Surface Dock, which lets you one cable access 4 more monitors, 4 HD monitors, or even 2 4K monitors by simply plugging in the dock, and you can take advantage of all the GPU that's in there. It might not solve this or the GPU part of more, but if you had your Surface Book with the GPU plugged in and you simply attach the docking cable, you can go to up to 4 external monitors or 2 4K monitors if you wanted to. So that sounds like a possible solution for what you're looking for. So we can talk more afterwards. Okay. Sounds like they're pretty intense in what they're doing.
For the Surface Pro book, I know we went with a thinner screen, but was there any thought put into putting maybe at least one more USB on the screen itself, so when you detach from the keyboard, you can still use maybe a wireless presenter or any device like that?
Yeah, the question is on Surface Book, did you think about putting a USB on here? And so on this device, the thinness is actually thinner than a typical USB, and so you can't even fit a USB Type A on here. The discussion has come up about Type C. It's not in this device just because of where that's at in a technology form. But this is fully Bluetooth capable, so we try to encourage users who want to access this to use Bluetooth devices, mice, keyboards, or clickers. The other interesting part is this can be charged separately using our Surface charger. You can also dock to this separately. So if you had that docking station and you put the docking connector on the bottom, this will do everything you can do from that docking connector. Drive those 4K monitors, have an extensible desktop that has USB in it or even Ethernet in it from just this device.
Yeah, I believe it was on the Surface Pro 2. They had another type of keyboard that was like a music creation add-on. And I always thought, wow, and there was talks of all these unique different keyboard editions that could
Yep.
be used. That was the only one I remember hearing about, and I was excited to see more come out. Or maybe even third-party keyboards or third-party devices that could be attached to the Surface Pro, but that never really...
Yeah, the question is on Surface Pro 2, we launched a Remix keyboard that actually had DJ controls on the keyboard that let you do things with feel. And the idea behind the keyboard interoperability was that you'd put these different surfaces in front of you and be able to use them. We made the keyboard. We had a contest. We had great feedback on it. Just to be totally transparent and honest, the market demand wasn't there. And so the capability is still there on our devices. We have tons of prototypes in Redmond of those kinds of things, but not something we've leaned into from a marketing perspective. Whether it was a concept that was ahead of its time, because people were trying to understand what Surface was at that time, or something that wasn't right for market, we're always looking at. And so if we don't talk roadmap typically, but it's not to say we aren't working on concepts that fit those kinds of ideas. Okay, we'll do one more question. I'll go here, and I'd be happy to talk later if needed, but just in the sake of time. It's a good question. The Surface Book, have we ever seen the Surface Book keyboard for desktop? We've been doing keyboards for over 30 years at Microsoft. That bottom left-hand thing I showed you wasn't something we came up with on Surface Book. It's actually the playbook we have for keyboards. And so that recipe that we have does go into our desktop keyboards. And we have some keyboards that are in market that use the same key switch technology, field technology. They go through the same sound testing. Whether we'd ever take that exact key switch and put it on a desktop with the trackpad, probably not something we would typically do, mainly because desktop keyboards take advantage of the bigger space. And in that space, they do stuff ergonomically or bigger key pitch, a little bigger key pitch layout. But the DNA of our desktop keyboards does use all of that technology in it. And we have some really good desktop keyboards from a typing experience. So, okay, with that, I'm going to ask Tim Bakke to come up. He has an announcement to make, and then we'll wrap. We're a little over time. I apologize.
Thanks, everyone. Thanks, Steve.
Yeah, thank you.